Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 28th. Looking at significant wave heights for the North Pacific Ocean, we see a gale developing or producing 25-foot seas on the dateline. They were actually higher yesterday, and those seas, really swell, is pushing towards Hawaii. Swell is also hitting Hawaii from a previous gale that fell through the Gulf and is now off the U.S. west coast, and some energy from that storm, along with suspected wind swell, is about ready to also hit Northern California. And of course, a tropical system is in the far west Pacific, tracking west, and of no concern, with no expectation that it's going to recurve to the northeast. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough or a dip in the jet, sort of like that right there. And what that does is you see winds right here. What is that? About 170 knots, pushing, ridging northeast off Japan. When you see the jet pushing to the north, underneath that typically forms high pressure, but when you see it dipping south, that's what we're looking for. That forms a trough. A trough aloft, that helps support like an eddy flow in there, sort of a counterclockwise circulation in the upper atmosphere and also down at the surface. That's the hallmark of low pressure. Of course, low pressure generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, creates surf. So we do have a bit of a trough. It's really a remnant trough. It was a little bit steeper over here, maybe 24 hours ago. Still, it's on just west of, or just east of the dateline, supporting low pressure development. Then you look here, there's also another trough off the U.S. west coast, but not a whole lot of wind energy feeding it, not very steep, not doing a whole lot to support gale development. All right, let's go take a look into the future, see what's going on. The trough on the dateline as we get into Monday kind of still sits there, not doing, actually a little bit better wind energy feeding into it, maybe 150, 160 knots. So some more support for gale development. That continues, more wind energy, and Wednesday builds off of Japan. 1, 2, 3, that's 170 knot winds. The trough still hanging here just north of Hawaii, a little bit pinched, not super well defined, but there's a good amount of wind energy in the jet stream offering some help. Now notice there's this big ridge developing off California, and when you have, so troughs support low pressure, ridges support high pressure here. So that probably means a likely wind machine for California, north winds down the coast. You can even see the flow in the upper atmosphere. It's pretty pronounced there. Anyway, the trough pretty much washes out as we get into late Thursday. No support for gale development. A little bit of something that almost could be considered a trough here, but it kind of looks like the jet split here. Two distinct flows, the northern branch, the southern branch here. The southern branch is the one we're most interested in. Some of the energy from the northern branch falling into the southern branch. Let's see how this plays out. Nope, you actually get sort of something that looks like a trough as we get into Friday night and Saturday in the far west Pacific. But then here the jet clearly is split off Japan. That's not a good sign. That typically means low energy, low wind levels in the upper atmosphere, and that is often a sign of the inactive phase of the MJO. And those of you that have been following us for a while know the inactive phase of the MJO is not good for supporting storm development, exactly because it cuts off the wind flow to the jet stream. The jet stream gets weak and it splits, and then you're in trouble. And that's sort of what it looks like is forecast to happen through at least a week out from now. And you see just no wind. Things look very weak. So this is probably the last little bit of support for gale development. This is a week out Sunday in the northern Gulf, a little weak trough, the last bit of any energy associated with what was a weak active phase of the MJ moving out, the inactive phase coming in. At least that's what it looks like in the upper atmosphere. Let's go down to the surface and take a look. So here we go. Surface level pressure, surface level winds. We see low pressure, very weak, was about 992 millibars roughly on the dateline. Tiny area, 35 knot winds. We know we saw the 00 hour forecast model sees 26 feet in that area. And then a little bit of low pressure up here in the Gulf, but really no wind associated with that. High pressure off the U.S. west coast, and there's our tropical system moving west into the Philippines. Roll this out. The low, yes, we know there's sort of a pinch trough here as we get into Monday, but it's just doing nothing really to support low pressure development. Ridge building in the east, we saw that, and sure enough, there's our high pressure. There's our north winds at 25 knots off the California coast on Tuesday. Let's go back. They actually start building Monday morning. Pretty much looks like just a washout for California unless you're down into Southern California. Roll this out. We know there's sort of here a trough supposed to develop over in the far west Pacific as we get midweek. And yeah, you see the low pressure, but just not well organized because we know it's just not a well organized trough. Continue rolling this out, a little bit of a low in the northern Gulf as we get into Thursday night, but just way to the north, not doing anything. Broad, unorganized low in the West Pacific on Thursday night. Friday, it all just kind of falls apart. Not a whole lot going on. Nothing clearly to support swell development other than wind swell at best. This is not the time of year you want to be tracking or trying to grovel for windsurf. We would be expecting real surf this time of year, and it just doesn't happen. And then here comes the high pressure buildup, just as we thought. Split jet stream here, 180 hours out, and things just not looking very positive. All right, let's go take a look down at the surface, the effects of wind on the ocean. Now, we're going to go back in time just a little bit to Thursday night, a couple days ago, 3 days ago or so. A low-pressure system did fall through the northern Gulf, produced an area of 21-foot seas aimed at Hawaii, built to 22 feet as we got it through the day Friday, and then pushed out of the way. That swell is now hitting Hawaii, making some decent-sized waves. It's kind of more wind swellish than real, solid long-period swell, but waves are waves. And you see that those seas, 21 foot, continue to push into the Gulf into Saturday. That swell is poised to hit California, along with a bunch of wind, mainly central and northern California. So there'll be swell come Monday, but it'll be pretty raw and pretty ragged with north winds and high pressure in control. Now, another gale did develop on Saturday. Here, we'll actually go back. This system off of, we'll say, the northern Kuril Islands, 28-foot seas on Saturday, pushing to 30 feet. And notice they're falling southeast, targeting Hawaii well. Nothing huge by Sunday morning. Seas were down to 26 feet. There we are now. It's 25 feet. Let's switch the model. And there we go. All right. And those seas are to continue in tonight, falling southeast, then pretty much gone by Monday. Swell from this to push towards Hawaii. Again, a nice little pulse of swell for Hawaii. Maybe some minor energy for California, but given that this system mainly was, even when it was on the date line, and that's about 4 days away, assuming a 17-second period, probably not a whole lot of energy will result for any of the even exposed breaks in California, maybe 2 feet at 16 seconds or something like that from the west-northwest kind of thing. Anyway, roll that out, and then you see things just get very quiet very fast. We're into Wednesday here, nothing going on. Remember, low pressure tries to build in the western Pacific. Winds not strong, so one would not expect a whole lot in terms of seas. Another little gale tries to wrap up in the northern Gulf, just does nothing as we get into Friday. And then, yes, we have some 22-foot seas from southwest winds on late Friday night. Yeah, maybe some wind swell for Oregon or so. But that's about it. It's just, for this time of year, things looking very quiet indeed, and not particularly conducive to storm development. We'd like to talk a little bit about why. So that leads us to the long-term outlook. What's going on with the MJO and what's going on with the El Nino Southern Oscillation, ENSO. But what it also, the MJO situation and the ENSO, yes, they are long-term indicators of what's to come, but they also kind of explain why are things so dead right now. So we're going to get into that in little bits and pieces at a time, but we'll go through the usual drill here and look at the data and then try to put the pieces together and explain why those pieces are doing what they're doing in relation to the picture right now and what it will be a couple of months from now. All right, so as usual, we're looking at winds across the equator. This is the East Pacific here, West Pacific there. There's the equator. That's New Guinea there. Dateline right there. These winds from the TAO buoy array. So you can see just looking at the arrows, a lot of east winds. That's pretty typical. Trades blowing pretty hard. The nice thing is they make it to the dateline and then they die. If anything, the winds are actually blowing out of the west in what we call the Kelvin wave generation area. That is, when you get west winds from about 170 west, 5 degrees north and south of the equator, a whole way over to New Guinea, right in this box right here, you get these west winds. That takes warm water that's normally pooled up here, helps push it to the east in the form of a Kelvin wave, and that's a precursor to the development of El Nino. All right, so what are these winds doing in relation to normal for this time of year? Anomalies, they call it. What are the winds doing compared to what is normally happening at this time of year? And we're just looking at the arrows. You can see water temperatures too, but what we're interested in is right now, see the arrows are not really doing a whole lot. If anything, maybe a little bit out of the east, meaning right in this area, trades are maybe a little bit stronger out of the east than normal, but not too much. But over here in the West Pacific, sure looks like we have a westerly wind burst going on. That is, the active phase of the MJO is creating westerly, not just anomalies, but winds and, conducive to Kelvin wave development. So that's kind of a good sign. One would think that we should have a pretty decent run of swell going on. And the reality is we have. And there are low pressure systems going on, and there is swell in the water that we've talked about already. So far things kind of look semi-okay, but the reality is for nearly Halloween time frame, we haven't really had a significant class swell. I mean, something that's 15-foot Hawaiian anywhere. The Pacific's kind of like half asleep and sort of just going through the motions. So we've been saying that's all attributable to La Nina. I mean, we've been in La Nina for 2 years. The atmosphere is trying to move from a La Nina pattern, which it's pretty typical to not have a lot of storm development. That is, during La Nina, storms tend to be smaller than normal. They tend to last shorter than normal, and their footprint, the fetch just doesn't get as good, isn't as large, doesn't get as much purchase on the ocean surface. So the swells that result from these systems are smaller, less frequent, and don't have as much energy as compared to normal. Likewise, or counter to that, if you have El Nino, the exact opposite's in effect. A lot more storms, a lot bigger, a lot more wind, a lot more surf, blah, blah, blah. You've heard it before. So let's go take a look at what winds have been doing the past 5 days. In this chart here, okay, so there's South America, there's Mexico, there's New Guinea there, Philippines there, Kelvin wave generation area from New Guinea. So right here, 5 degrees, there's the equator right along there. So 5 degrees north and south of the equator, right in there, that's the box we're looking at. We see westerly anomalies in the Kelvin wave generation area on the 22nd, the 23rd, the 24th, 25th, 26th. Okay, so that looks pretty good. That would lend one to believe that the active phase of the MJO was in control. And then we look at the forecast here, but we can also see past history. So this is zonal wind anomalies, 850 millibars, same thing as what we looked at before. And the oranges and the reds are westerly anomalies, but what are we looking at here? There's the whole planet on one chart. So the date line runs right down the middle of the chart, 180 degrees west, right there, okay? So the Kelvin wave generation area, or we could generally call it the West Pacific, is between these two tick marks. You see in September, we had a little bit of easterly anomalies right here, maybe associated with the inactive phase of the MJO, but pretty short-lived. But here's where we've been for the past, since, let's say, mid-October. Strong westerly anomalies, a westerly wind burst in the West Pacific Kelvin wave generation area associated with the which one would think would be the active phase of the MJO. But here's the forecast. This goes for another day, maybe two, and then it all falls apart and we see easterly anomalies building, supposedly, in the Kelvin wave generation area. Now, this hasn't been on any chart until it started popping up on this chart. This is a short-run dynamic model. It's probably the GFS model. The longer-range models that we're looking at, the CFS model, haven't been showing it. They show just maybe a weakness of the westerly winds, but this is now looking like a full-on easterly wind burst. Not good. This would be associated with what one would consider the inactive phase of the MJO. So that's not encouraging. Basically, what we're saying is the models have been saying we're supposed to have westerly anomalies from here on out. For months they've been saying it. And Here we go, boom, easterly anomalies showing up. So the long-range models and the short-range models are kind of out of sync, and there's some details that are kind of getting lost in the wash, and they're not particularly good in terms of feeding or supporting the development of any kind of a significant El Nino. Now, part 2 of this, let's be clear. We're only, 2.5 years, 2 years out from what was a large and strong El Nino. Let's see, 2014, 2015, okay, 3 years out, all right? So one would not expect a large or strong El Nino to develop at all. In fact, in the normal history of things, about 3 years after a major El Nino, all you get is neutral a neutral El Nino pattern. And the fact that the models were saying, are sort of hyping up, and there was some hype going around about El Nino developing. Well, yeah, maybe the models are saying that, but when you really look at it, and if you've been following this stuff for a while, you go, that just really doesn't make a whole lot of sense. So we shouldn't be shocked when all of a sudden we get into, okay, this is supposed to be the prime time when this quote-unquote El Nino is supposed to be developing. All of a sudden you see easterly anomalies, and, the sense that El Nino just really isn't happening, and when you think about that a little bit, you go, well, maybe that's not such a bad thing, really. Because what this will mean is it'll allow more latent heat energy to build up in the ocean so that when we finally do get a real El Nino, it will be a real El Nino, not some like half-baked Madoki El Nino thing, and then have us fall right back into another 2 or 3 years of La Nina. So if this El Nino falters or doesn't even form at all, honestly, it's not the worst thing in the world. It would actually be better for us long term. Let heat energy build up in the ocean so that we can have a legitimate El Nino, so we can have a legitimate storm track, and so that we can get some moisture into California. We'll see. Let's go look at more indicators. All right, so let's look at outgoing long-wave radiation model. This is basically amount of sunlight reflectivity off the ocean surface. If you have more sunlight reflectivity, these positive numbers, that means high pressure. That means the inactive phase of the MJO, and that's, look at the model here. It says things are kind of neutral right now, but we get reds and yellows over the next 2 weeks. That's the inactive phase of the MJO with the active phase building over in the Indian Ocean. Okay, interesting. That's per the statistic model. The dynamic model says exactly the same thing, so they're kind of in sync. These models have kind of been in opposition the past couple weeks. They're in sync, so it sort of looks like the inactive phase of the MJO is coming, and the GFS model that we just saw said easterly anomalies developing. That's a typical symptom of the inactive phase of the MJO. Phase diagram charts, another way of looking at the active phase of the MJO. So assume you're looking down on the North Pole. The MJO travels from west to east around the planet, or from the Indian Ocean over the maritime continent, across the West Pacific under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. The closer it is to this circle, the weaker it is. So there's the active phase in the, we'll call it the East Pacific. Extremely weak, and forecast to race to the east and get even weaker and be in the maritime continent 2 weeks from now. And that's pretty much what we saw on the previous chart. That's per the ECMF model. The GEFS model basically saying some variant of the same thing. The upper level model. Okay, so this is at jet stream level, but the greens basically say areas favorable for precipitation. One could say that's the active phase of the MJO. The yellows are, of course, the exact opposite, the inactive phase, or dry areas. So what this says is, yeah, we've kind of got something that resembles a weak active phase of the MJO, but you see it moving to the west over Central America by, let's say somewhere late in the second week in November and out of the picture, and the inactive phase of the MJO moving into the Pacific. So all these models are pretty much in sync. This inactive phase is supposed to move across the Pacific, moving into Central America on, let's say, December 2nd, but a new active phase pushes into the West Pacific on, let's say, mid-November. So given what we're seeing in all the models right now, we're just going to say 2 weeks out. Looks like the inactive phase of the MJO is in control. Whatever active phase there was and what is fading feeding the storm pattern at this particular moment in time is going to be very short-lived. And we saw that on the 1-week model. About a week from now, everything falls apart, and then we suffer for a week and a half, maybe 2 weeks, and then things start waking up again, supposedly, our forecast to wake up again in the West Pacific. So that's not all that horrible. And then the CFS model. This is the real long-range one. I mean, so here, and this is the same deal. Whole planet on one chart. The West Pacific or Kelvin wave generation area between these two tick marks going down. You see, this is zonal wind anomalies, 850 millibar winds, or winds up at about 4,600 feet up in the atmosphere. See, west anomalies, west anomalies, west anomalies. You see this purple here. That's the low-pass filter, favoring low-pressure development in the central or in the Kelvin wave generation area. So this all looks very much, this is what has actually happened. This isn't some model projection. I mean, this is what's been going on since August 4th, and you see it. It clearly looks like some sort of an El Nino pattern. Now, the interesting part here is this version of the model says that low-pass filter thing, it's all supposed to die out here in about 2 weeks. But it continues to show westerly anomalies in the Kelvin wave generation area, but fading. And, still there, but just not as strong. Here's our little inactive phase. There it is right there, the inactive phase of the MJO. A little bit of easterly anomalies pushing into the West Pacific, then backing off. But then at least this depiction of the model says that maybe this El Nino thing's supposed to certainly lose some punch as we get into November, even though westerly anomalies are supposed to continue in the Kelvin wave generation area. Now we'll look at the same model. So yes, that last one we looked at was yesterday's run. This is today's run. Same deal. Here is the West Pacific between these two tick marks going up. This is past performance here. And you see there's been a fair amount of westerly anomalies in the West Pacific. And if you look forward, just eyeballing it, they're supposed to continue. Yeah, we get some weakness right in this first 2 weeks of November time frame, presumably associated with the inactive phase of the MJO. Let's overlay the MJO. And that's kind of interesting because here's the inactive phase according to this one. It's supposed to be dying. Another little pulse of it, but they're so very weak, it's kind of hard to discern what's really going on. But it's showing that westerly anomalies are to continue the whole way through November, December, and solid into the end of January. So this sort of pattern, with a very weak El Nino, continued westerly anomalies, is clearly indicative of El Nino. We'll overlay the low-pass filter, and now this version says 1, 2, 3 contour lines are already in play, meaning low pressure is fully entrenched in the Pacific, and it's supposed to build to 4 contours as we get into late December, early January. So there's a bit of head scratching going on here. This model seems to be overhyping the El Nino signal. The other, they're both the CFS model too. The other one seems to be saying it's going to fall apart. What's going on? I don't know that we have an answer here, but there's a little bit of ambiguity, I think, into this, the strength of this El Nino, and I am beginning to think that this version or this depiction of it is overhyping things a little bit. That said, just one more MJO bit of data here. So this is this year. This is the strength of the active phase of the MJO. When the active phase of the MJO is stronger than normal, and more frequent than normal, that would tend to hint at El Nino. So here's January 2018. We're just looking for anything that is above, 2 standard deviations above normal. I see 1, 2, 3, 4, 5 instances of that so far this year. Last year, remember, the surf was just horrible. Things were bad. The summer was dead. There was only really, I'll call, 2 legitimate active phases of the MJO. You go into 2016, there was 1, 2, 3. They're so on the border. There, maybe 3 in 2016. Now 2015, that was our El Nino year. 1, 2, we'll call that 3, 4, and we'll make this 5. So this was clearly an El Nino year. This kind of looks like it is, but maybe not. I mean, but look at the strength. They're up to 4 standard deviations here. We had one that was 3.5, but all the rest of them are between 2.5 at best. And then you can go back a couple of years. I mean, you can go back January 2013, and you have practically nothing. January 2014, and practically nothing. And then you have to go back to, what's this? 2012, we had a pretty little, I mean, you just eyeball this stuff and you go, well, between that year, which was clearly a super El Nino year, and this year, these are by far the most 2 active MJO seasons since before January 2011. Head scratcher. You would think there would be a stronger signal in the ocean here. But the one possible explanation is there really isn't that much latent heat energy in the ocean. Yeah, we're having the active phase of the MJO, but its effects just aren't as pronounced because back here there was a lot of heat energy in the ocean. Here, there isn't. We're still trying to recover from this El Nino. So what's going on in the ocean? We're talking about latent heat energy. It's latent heat energy in the ocean that then turns around and drives the atmosphere, not the other way around. The atmosphere does not drive the ocean. It can help reinforce it, but the ocean really is what drives the atmosphere. Okay, so standard drill here. We're looking at data from the TAO buoy array, West Pacific here, East Pacific here. These are the anchor lines on the buoys. The X's are the sensors. You see warm water in the West Pacific. A little of the 28-degree, that's 30 degrees there, Celsius. The 28-degree isotherm actually backtracked a little. It was at 153 this week. Now it's back to like 157, 158. The 24-degree isotherm, line, is pushing well into Ecuador, suggesting that there's warm water pushing off to the east. Then we look at anomalies, differences from normal for this time of year. We see clearly a Kelvin wave. That is a pocket of warm water from previous westerly wind bursts in active phase of the MJO. In the East Pacific, it's interesting though because last week the bolus of warm water was back here, and now all of a sudden it's practically in the East Pacific. That's moving a couple thousand miles in a week. That's probably not exactly accurate, but again, this is, you don't have infinite number of sensors. The satellites can't peer down into the ocean exactly and know what's going on. We think we know what's happening here, but for right now, it's saying the peak of this active phase or of this Kelvin wave, which was not even supposed to really be pushing into Ecuador until at least mid-October, mid-November, is poised right off the coast at this moment in time. Interesting. The GODAS data pretty much says the same thing. It's a higher res model, same sort of deal. It says most of the warm water is right here at roughly 120 west, but there's still a pretty good amount out to almost the date line. But this is clearly a Kelvin wave pushing into Ecuador, breaching the surface right along in here. When one looks at this and looks at all the warm water that's supposedly gurgling up on the equator, one would think a pretty clear El Nino footprint would be observed on the equator on the ocean's surface. Also notice, though, back here, no more westerly anomalies. We say some cool anomalies, but probably not. It's actually looking less like that than it was even last week. So maybe this is just the upwelling phase of the Kelvin wave cycle. Sort of it breaks before you get another westerly wind burst and another Kelvin wave. Or maybe not. It's hard to say. So then you look at this. This is sea level anomalies. This is JSON-2 data. The JSON-2 satellite, it basically is to within like 2 centimeters accurate to the ocean surface height as compared to normal. And you see positive anomalies from there is New Guinea, Ecuador right there, Central America there, filling the entire equatorial region, but the peak of it right here, right about 120. The highest anomalies, what are these? 10 centimeter anomalies. So, of course, warm water at depth expands a little. It creates a bump on the ocean surface, and that's what this is picking up. So the JSON-2 satellite is saying most of the warmth probably is right around 120 west, but there's still a great flow continuing over the entire equatorial Pacific. And then upper ocean heat anomalies, upper 300 meters of the ocean surface. Of course, last year, November, December, you see blue anomalies here. This is the East Pacific here. West Pacific is over here. You see warm water, these oranges, slid across into the East Pacific in January of this year. First little mini Kelvin wave, and that kind of killed La Nina. And then upwelling phase of the Kelvin wave cycle. And then a far stronger Kelvin wave developed in February associated with the active phase of the MJO, westerly winds. Of course, that's why we kind of follow it. Not only does this does the active phase feed the jet stream, it also creates Kelvin waves if there's warm water present, it lasts long enough, etc. Sure enough, we got that. Here it is. A Kelvin wave made it the whole way across the Pacific, but it was weak. It didn't really do anything other than to just sort of really set temperatures a little bit above normal, but not much. Then we got another westerly wind burst in the August-September timeframe associated with westerly anomalies in the Kelvin wave generation here. Here is our Kelvin wave, and it still hasn't reached Ecuador. It's hanging somewhere as of today, probably peaking somewhere between 140 and 120. So probably about like what the other data suggests, but still won't really make it into the coast of Ecuador till another couple of weeks at a minimum. So here's where the head scratching really starts. So last week we looked at this area. This is sea surface temperature anomalies, difference from normal this time of year. Things were warming up very nice, both sides of the equator, from Ecuador on out to the date line. We go, hey, it actually looks like El Nino. And then you know what started happening about 3 days ago? These temperatures just started cooling. And yes, it's warm, but this isn't an El Nino. This isn't, yeah, I guess you'd call it, it's not a Modoki El Nino either, because then all the warming would be brought out here. It's just kind of this generic drip of weak warm water, not strong enough, not consistent enough to really do anything atmospherically, at least at what we're seeing here. The point being, yes, we have warm water, but it doesn't stay, at least so far, it hasn't hung around long enough to really do anything in the atmosphere, and we thought it was starting to do that last week, and now it's just wimping out again. Yes, we have weak little warming along the coast of Peru, but you would expect to see sort of this triangle thing going on here if it was a legit moderate plus El Nino. We're not seeing that. If anything, this looks like just sort of an El Nino that's really not happening. I don't even think we'd call it a Modoki El Nino. It's just not there. Now, the interesting part is we saw there's massive amounts of warm water under the ocean surface here, supposedly erupting on the surface, but the signature on the surface just isn't that strong. And so that's telling me that something isn't quite right. Either the models are overhyping what's going on under the surface. These Kelvin waves aren't as strong as they thought. There's not, probably the real culprit is, there's just not as much warm water in the West Pacific as one would expect. So even if you start having westerly winds and you get Kelvin waves, the Kelvin waves end up being weaker and their impact is weaker. All right, continuing on. What's the trend the past 7 days? Clearly, you can see it. The blue is cooling. Cooling temperatures, just 7 days worth of cooling. You see it right here, right where it was warming so good a week ago. It's cooling now. You know, that sort of smells of the inactive phase of the MJO setting up. Yeah, we had the active phase of the MJO. That's what's made the storms past couple of weeks. It's dying. We're getting trades building here. That's causing upwelling. Whatever the Kelvin wave's doing is sort of getting stomped on by the trades and the upwelling, and it's just not allowing the heat signature to manifest itself on the ocean surface like one would expect, and you get this kind of a wimpy El Nino situation. The zoom back view, same deal. Sea surface temperature anomalies. Yeah, it's warm here. Certainly isn't La Nina. We'll take that. Very thankful for that. But it's not El Nino either. It's just kind of noodling along. In fact, let's go look at sea surface temperatures. Sea surface temperatures compared to normal right now, minus 0.1 of a degree, basically, right there. The trend, yeah, this is right up along Ecuador and Peru. This is not any official El Nino monitoring region, but it kind of gives you an idea what's going on there. You see, yeah, we had a pretty good spike there, but for what? 2 weeks? Maybe 3? That doesn't make an El Nino, for sure. And before that, it was all below normal. So no clear signs of El Nino close to the coast. In the official El Nino monitoring region from 120 west out to 170 west, 5 degrees north and south of the equator, yeah, we were noodling along about dead neutral all summer long. And then in September, right like what the model said. We were supposed to get this big uptick associated with that big Kelvin wave that we were just looking at, warm water moving to the surface, but all of a sudden, boom, things just kind of plummeted. Yeah, today we're at 0.6 of a degree below normal. And if you had 5 months of that, yes, one would officially call that El Nino, but you know where the dividing line is between El Nino and no El Nino? It's right here at 0.5 of a degree. It has to go for 5 months. We're nowhere close to that. We're at a month and a week right now and barely in the El Nino range. So this is, again, speaks to this. Whatever El Nino we got, it's kind of weak. It's trying to get going, but it keeps getting stomped on and just can't quite get itself together. It all smells of there's just not enough energy in the atmosphere to get a real El Nino out of this thing. So the ocean really, from a surface temperature perspective, isn't showing any signs of El Nino. Not really. I mean, it's not showing La Nina, but not El Nino. So, and typically it is, the change has to start in the ocean, then it affects the atmosphere. So what's going on in the atmosphere? What's the atmosphere thinks is going on? We look at the Southern Oscillation Index. Difference in pressure between Tahiti and Darwin, Australia. When you have positive numbers, that's over a 30-day period. That pretty much says inactive phase of the MJO. When you have negative numbers, that means active phase of the MJO. Today, 5.93, so weakly positive. And we kind of look at the trend. It's just been noodling around, mainly more positive than negative, it seems like, in the past month, suggesting, we'll call it a weak inactive phase of the MJO. 30-day average, well, we were negative, so this back here in October would suggest the active phase of the MJO. Now it's turning to positive 0.48, which isn't very much, saying neutral or maybe weakly inactive. We think the inactive phase is probably going to build a little bit more for a week or two. But the 90-day average, strip all the MJO, strip everything out, and where are we? Minus 4.66. Okay, so what's that? We just look back for the entire month. It's gone nowhere. We've seen no clear indication. It was 0.481 a month ago, October 1st. It's 0.466 now. No indication that we're moving at all towards El Nino. What we're doing is sitting neutral, about neutral, or maybe just a couple of ticks into the El Nino range. You really want to see this at minus 10 or minus 15. In fact, here's the 30-day SOI on a graph. You can see this was back in our last El Nino, January, April, the last bit, 2015. There we go, minus 10, minus 15, minus 20. And these up and down motions are the phases, the upward spikes are the inactive phase of the MJO. This is the active phase of the MJO, inactive, active. Then you see we got in 2016, basically we had La Nina or neutral, and then 2017, definitely La Nina. Now here where we are, we're getting into the fall of 2018, and yeah, we're a little bit below neutral, but not clearly in El Nino range at all yet. And then our last little bit of data, the ESPI index, very much like the Southern Oscillation Index, only this is difference in precipitation in the area north of Darwin, Australia, and the area north of Tahiti. This is even probably a better index because if you have warm water here, remember that's what we're seeing, there's Ecuador right there. If you have warm water here, you get more evaporation. If you get more evaporation, you get more precipitation, and that's kind of the hallmark of an El Nino is warm water in this area and lots of precipitation moving into Peru. The index today is minus 0.16, which is, just a hair on the side of being drier than normal. Certainly not wetter than number. We want to see this moving positive, like at +5 or something like that. We're not seeing it. Nothing close. So all this is saying is we're not in La Nina, but we're certainly not in El Nino either. All right, so the official forecast for sea surface temperatures in the Nino 3.4 region. All right, they have, we'll just say it, they've backed off a little bit more. The model was saying at one point we'd have temperatures at 1.5 degrees above normal. Now they're saying, well, here's October, right? And they're saying temperatures were 0.6, and it's supposed to be going up as we get into November to 0.8 to maybe 1 degree above normal. I think that is not realistic given what we're seeing at this point in time. Unless something significantly changes in the next 2 weeks, I would bet we'll be lucky to eke out 0.7 of a degree above normal, and maybe not even that. I'm not complaining. You know, it seems like it was too much to hope for any sort of a legitimate El Nino anyway this year. I mean, it's not been long enough. There's not been enough time for the ocean to recharge and heat to build up. So this seems to be on the high end of the scale. And you look at all the other models, you know, and the consensus and all that, they're all saying 0.8, 0.9 tenths of a degree above normal and some sort of a weak El Nino this year. I think that's probably even on the high side, and maybe 0.6, maybe 0.7 if you're lucky, and barely call in an El Nino. I don't really want an El Nino at this point. Just let it be neutral to bias, you know, half a degree above normal or something, and give us another 2 or 3 years of warming building up. Just get us to a neutral, normal winter. Now, that gets us to the point, why is there no real surf? Why are things not, you know, doing what they should? That's because clearly there's some sort of La Nina momentum still going on in the atmosphere, and things, you know, the temperatures are just recently starting to rebound to normal. It'll take 3 months before that starts working its way into the atmosphere, so we're talking January before winter really gets going in earnest, something like that. That's not unexpected. We're thinking the storm track really isn't going to start looking good till late December, early January, and then maybe we'll eke out something in terms, you know, surf-wise, in terms of precipitation into California. We're not holding our breath. Certainly nothing above normal at this point in time. Just normal, and we might be lucky just to get that. It really depends on what happens with this next Kelvin wave. In the next week or two, let's say next 2 weeks, we'll know. If it all of a sudden starts warming up on the ocean surface and things get back to normal, great. We'll start getting excited. But at this point in time, we are going to be very, very cautious about trying to suggest any significant storm track or, you know, enhancement for this winter. And maybe in the next 2 weeks, we might even downgrade our forecast for the swell potential rating for this winter. But for right now, we'll hang with it. We said it was going to be a 6.5 out of a 10. We thought maybe we'll pull it down to a 5.5, but just give it a little bit of time. 1 week or 2 weeks does not make a whole trend for the year, so we're going to give it a little more time. So for now, swell is hitting Hawaii, a little bit of swell coming towards California, but with a bunch of wind. And after that, the storm track falls apart. Things are going to get pretty quiet for 2 weeks. Probably a good time to go take care of business, to go do chores. If one is to believe the longer-term models, oh yes, in the southern hemi, nothing's going on there. Whatever swell is in the water is in the water. It's hitting. It's not going up from here at all. It's going down. So the whole entire focus now is the North Pacific, and the inactive phase of the MJO, it looks like, is sort of in control for the next 2 weeks. And things are going to settle down. So go take care, you do your chores, you know, work overtime, whatever you got to do, because the assumption is, at least now based on the models, that the active phase will resurrect itself in the latter part of November around Thanksgiving, and then things will start getting active again, and we'll get into a good swell pattern. So that's it for this week. We'll do it again next week, same time, same channel. Keep your fingers crossed for something better, and thanks for watching.